Imagine 10 people, each from different walks of life, standing in a line. They are unaware of the adventure that awaits them. Suddenly, they are captured by aliens. These extraterrestrial beings are not here to harm them, but to challenge them. The aliens love to play games. They are playful and mischievous, always looking for new ways to entertain themselves. This particular game is all about hats. Not just any hats, but special ones that hold the key to their freedom. The rules are simple, yet the challenge is immense. Each person is given a hat, but there's a twist. Each person gets a hat placed on their head. They can't see their own hat, but they can see everyone else's. The hats are either black or white. There are no other colors, making it a binary choice. The challenge lies in the fact that they can't see their own hat. They must rely on the information they gather from observing others. They can see the hats of everyone in front of them, but not their own. This creates a unique dynamic of observation and deduction. The person at the back of the line has the advantage of seeing 9 hats. They have the most information to start with. Conversely, the person at the front sees none. They're at the mercy of the guesses made by those behind them. Starting from the back, each person must guess the color of their own hat. They can only say black or white. The pressure is immense. One wrong guess could jeopardize the entire group. They must use logic and the information available to them. To win, at least 9 out of the 10 people must guess correctly. It's a test of teamwork, strategy, and mental fortitude. Can they do it? The fate of their freedom rests on their ability to work together and think critically. The key to winning is a simple idea: parity. Parity is a fundamental concept in mathematics and computer science, often used to solve complex problems with elegant simplicity. Parity means whether something is even or odd. This binary distinction can be incredibly powerful when applied correctly. For instance, in coding theory, parity checks are used to detect errors in data transmission. In our case, it's the number of white hats. Imagine a scenario where each person in a group is wearing a hat, and the color of the hat signifies a specific piece of information. Before the game starts, the people make a plan. They gather together to discuss and strategize, ensuring everyone understands the rules and the significance of the hat colors. They agree that black means an even number of white hats. This agreement is crucial because it sets the foundation for their strategy. White means an odd number. By establishing this code, they create a simple yet effective way to communicate complex information without speaking. This code will help them survive. With this understanding, they can navigate the challenges ahead using the power of parity to their advantage. The simplicity of even and odd can be a lifesaver in critical situations. The last person sees all the other hats. This is the most important guess. Let's say they see 3 white hats. 3 is an odd number, so they shout white. They might be wrong about their own hat color, but they have given everyone else vital information. Section 4, a chain of logic. In this section, we delve into the fascinating world of logical deduction and reasoning. Imagine a scenario where a group of people must determine the color of the hat they are wearing based solely on the information they gather from observing others. This exercise in logic is not only a test of individual reasoning, but also of collective intelligence. Now, the next person knows something crucial. There's an odd number of white hats in the line, including their own. This piece of information is vital because it sets the stage for a chain reaction of logical deductions. Each person in the line must use this knowledge to infer the color of their own hat. They can see 2 white hats in front of them. 2 is even. This observation is the first step in their logical process. By knowing that the total number of white hats must be odd, they can deduce that their own hat must be white to make the count odd. To make the total odd, their hat must be white. They confidently say white. This confident declaration is based on the logical deduction they have made. It's a moment of clarity and certainty, a testament to the power of logical reasoning. Each person uses this logic. As the information travels down the line, each individual uses the same logical process to determine the color of their own hat. It's a beautiful example of how a simple piece of information can lead to a cascade of logical deductions. They listen to the guesses behind them and count the white hats they see. By combining the information they hear with what they observe, each person can accurately determine the color of their own hat. This exercise highlights the importance of careful observation and logical reasoning in problem solving. Section 5. Thinking your way out. The hat puzzle seems impossible at first, but with logic and teamwork it becomes solvable. This puzzle teaches us the power of thinking step by step. It shows how even small clues can lead to big solutions. By using parity, these 10 people can outsmart the aliens and win their freedom.